Welcome to English for Professional Mechanical Engineers. My name is Yiji. In today's lesson, we will talk about the second topic of sustainable technology, energy conversion and conservation. In the previous video, we answered the question, what is energy? Energy is everything, is everywhere. It's one of the true constants of the universe. Because as long as there's been a universe, there's been energy. The whole universe actually is made of two parts, energy and matter. Nothing else, but just energy and matter. Matter is the part that we can see and touch. On the contrary, energy is the other part we can neither see nor touch. Or we can say that matter is substance, and energy is the mover of substance. The formal definition of energy is the ability to do work. In addition, we introduce the 5 types of energy forms. 1. Thermal energy. Thermal energy is the energy of an object determines how active its atoms are. A hot object is the one whose atoms and molecules are excited and show rapid movement. As a result, it has high thermal energy. On the contrary, a cool object's molecules and atoms will show less movement, and therefore it has low thermal energy. 2. Chemical energy. The energy exists inside the chemical bonds, and that energy bonds atoms together. Therefore, when bonds are broken, energy is released, as you may be aware when you burn things and see fire. 3. Electromagnetic energy. One kind of energy is created by movement of electrons. In addition, it's easily transported through power lines and converted into other forms of energy. Therefore, it is the energy form used mostly frequently at home or in the industry. 4. Nuclear energy. Nucleus is the core of an atom. When it breaks or fuses, it will lose some mass. Meanwhile, nuclear energy will be created owing to the mass loss. Based on the famous Einstein equation, E is equals to mc squared. Because c, speed of light, is a huge number, tons of energy will be generated based on tiny mass loss. We will cover this issue later in this video. Final type of energy form is mechanical energy. It's created when an object is moved. For example, when we kick a football, the ball will move. The motion demonstrates the mechanical energy. Okay, so here are the 5 forms of energy: thermal, chemical, electromagnetic, nuclear, and mechanical energy. I hope my rather rapid review was clear and will remind you their key concept. Okay, that brings us to one of today's topics, energy conversion. Can energy convert to other form? And how do they convert? Okay, this is the outline for these 2 sections about energy. In the previous video, we talked about the definition of energy and the 5 forms of energy. We will cover 2 topics for today's lecture, energy conversion and the law of conservation of energy. Let's move on to the first topic, energy convergence. All forms of energy can be converted into other forms, like nuclear energy to electromagnetic energy. For example, the sun's energy through solar cells can be converted directly into electricity. In addition, green plants convert the sun's energy, which is electromagnetic energy, into starches and sugars, which is chemical energy. Therefore, energy can be converted into other forms. Actually, we already introduced one energy conversion example in the last section. Here you are. Electrical energy is transported to your house through power line. When you plug an electric fan to a power outlet, electrical energy is transferred into what type of energy? Do you remember that? Okay, the answer is mechanical energy. So this case demonstrates that electromagnetic energy can be transformed or converted into mechanical energy. Now, let's take a moment to look at another example. This log is full of chemical energy because it's made up of combinations of hydrogen, carbon, and oxygen atoms, which is the stuff that makes up wood. All of the chemical bonds between all of those atoms contain energy. How do I know? Because if I were to apply enough extra energy, like heat, to break those bonds, it would release that chemical energy as fire, thermal energy. Therefore, the energy form is converted from chemical energy into thermal energy. Now, as you can see, that energy can be converted into other forms. But does the total amount of energy conservative? Or does the total energy increase or decrease after conversion? The law of conservation of energy. It means, firstly, energy cannot be either created or destroyed. Second, it may be transformed from one form into another, but the total amount of energy never changes. It is important to remember that energy can be converted into different forms. However, the total amount of energy doesn't change after transformation. Okay, we have covered two topics in today's lesson: energy conversion and the law of conservation of energy. Let's recap what we have learned in this section by asking some questions. First, let's try to draw a flow map to show the flow of the energy transformation from starting to driving a car. You should have 5 different types of energy. Here you are. This is how the energy converts from starting to driving a car. It starts by a battery, which can convert chemical energy into electrical energy. The electrical energy can supply the radio to create the sound, which is mechanical energy, because the sound is a kind of air vibration or air movement that our ears can hear. Also, the electrical energy from the battery can supply the mobile lamp. It will generate light, which is electromagnetic energy. And most importantly, the electrical energy can ignite the spark plug and generate power to drive a car, which is mechanical energy. Next question, the law of conservation of energy. Energy can be created or destroyed by ordinary means, true or false? Alright, the answer is false. Energy cannot be created or destroyed by ordinary means. It can only be converted from one form to another. Here is a supplement about the law of conservation of energy. If energy seems to disappear, then scientists look for it. And this kind of searching will lead to many important discoveries. For example, in 1905, Albert Einstein said that mass and energy can be converted into each other. He showed that if matter is destroyed, energy is created, and if energy is destroyed, mass is created. This is the famous Einstein equation, E is equal to mc squared. This equation demonstrates mass and energy are exchangeable at the atomic level specifically. In addition, this is an equation bringing us into the age of nuclear power. Human beings start to have the power to utilize nuclear energy. This is the outline covering what we have learned about energy. It includes definition of energy, forms of energy, energy conversion, and finally, the law of conservation of energy. This is the end of this section, part 2 of the introduction to energy. So much for today. Thank you for watching. Hope you have learned something useful from this lecture. Have a good time and see you in the next one. Goodbye.